BBC Learning Zone programmes pause now while the Open University scientist Russel Stannard explains why he believes the universe started with a Big Bang.
Scientists like Russel Stannard claim that the world began with a Big Bang. What's more, they say it happened 15,000 million years ago. How can they possibly know that?
The first clue comes as a message from the stars. Stars are gathered together in great swirling whirlpools called galaxies. And there are many of them. There are billions of galaxies. One of the interesting things about them is that they are all flying apart. The further away a galaxy is from us, the faster it is receding into the distance. So, what are we to make of this? I suppose these are two galaxies. Any old two galaxies, all right? And they're moving away from us. The further away it is, the faster it's going. If in fact it's twice as far away, it's going twice as fast. Now let's just suppose we'd taken a video recording of the whole thing and we played it backwards. What would we see? Well, the motion of the galaxies would be reversed, and we'd see that they come together at the same point in time. That would be the Big Bang. Running it the right way round, you get an explosion. Not only that, but knowing how fast that galaxy is going and how far it's travelled, we can work out how long it's been travelling. In other words, what the age of the universe is. And that's how we get the figure of 15,000 million years. The second clue is this. Every time we get a violent explosion, you expect it to be accompanied by a fireball. The Big Bang was no exception. But where has the light gone? Some of it obviously will have hit stars and planets and got absorbed, but stars and planets take up only a very small amount of volume, so the vast majority of that light must still be flying about in the universe. There's nowhere else for it to be. Yet when you go out on a starlit night and look up at the sky, you don't exactly get blinded by light. The reason for that is that when the light came out from the Big Bang, it cooled down. It became a kind of radiation which our eyes are not sensitive to. It becomes, in fact, like microwave radiation, the sort of radiation you get in a microwave oven. You can't see it, but it's there. In fact, an ordinary television set is a good example of a Big Bang detector. When it's not tuned into a broadcasting channel and you get this familiar snowstorm scene, then 1 in 100 of those snowflakes is due to the Big Bang. After its 15,000 million year journey, it eventually hits the aerial of your TV set. So far I've given the impression that the Big Bang was much like any other explosion. Bigger, yes, but ordinary in that sense that it must have happened at some point in space. And from that point all the debris came out and filled up the surrounding space. And you can imagine looking at it from the outside. But that's wrong. That can't be true because there's no space outside the universe. I and everything else have to be inside the universe. So when we talk about all the matter of the universe being squashed at a point, we must also think in terms of all of space itself is being squashed at a point. And at the Big Bang, it's the expansion of space that carries the galaxies on a flood tide of continuing expansion of space, which carries them apart. We have to get used to the idea of thinking of space, empty space, as being as real as matter itself. It's a property of the universe, a feature of the universe, and therefore it has to be created along with everything else. That being so, are there any other properties we should be thinking about? How about time? Time is a feature of the universe, so therefore that must also have been created at the same place. So, not only must we stop thinking about trying to imagine what lies outside the Big Bang, we have to stop thinking about what happened before the Big Bang. There was no before. Time began at the Big Bang. So the Big Bang marked not only the creation of matter, but also of space and the beginning of time.